Okay, good afternoon, everybody. I think we're about to begin for the 2:30 slot. So, my name's Robin North. I'm here to represent our company, Immense Simulations, and to talk about one of our collaborative R&D programs, which is just coming to a close. So this has been funded under the Intelligent Mobility Program through Centre for Connected and Autonomous Vehicles and Innovate UK. And it's called TALON. And the slides are working, which is a wonderful thing. I've got about 10 minutes to give you an overview of a best part of 3 years worth of work. So it will be necessarily fairly high level, but there's a few key messages I'd like to leave with you. And we have a stand over in the exhibition space, so please do come and ask questions now and learn more afterwards. So, there we go, okay. That will work, thank you. So, we're all here at LCV today, and we've been involved in various different ways in R&D programs around low carbon vehicles and around how they get deployed into real life and real service. And a lot of that links to this revolution that we're all seeing around different technology strands coming together. And increasingly we're seeing LCV become a forum for showcasing connected autonomous technologies and how they can be deployed into real life operation. And what it's giving us, and those of us who've been working around transport and mobility for a while, it's giving us a whole new set of cards to play around what does this enable us to do? How do we deliver better mobility services to the population? How do we deliver that more profitably? How do we have lower impacts on the environment? And so we've looked at that as a set of cards. We've got an unusually good hand to play, and they're coming. So autonomy is coming soon, depending on some of the demonstrations outside are fantastic of real vehicles running around, going right in them, autonomously. Connectivity's here now. There are probably more connected devices in this building than there are people, by probably a factor of 2. Electrification is here, is growing massively. There have been big announcements in the last few days about the UK's progress on that. And then sharing business models. So amongst the audience here, I'm sure many of you will have used Uber Pool, will have used other shared services in other parts of your lives. And that's having a big potential impact on how we deliver transport and mobility in the future. And if only it were that simple. So the problem that we have is that transport doesn't exist in a vacuum. It's part of a big, complicated ecosystem of different parties and different players. And we have these new technologies, and to make them valuable, to make them useful, we have to play those cards really wisely. We've got existing expensive investments in mass transit. We've got taxis and private hire fleets and operators who are competing for passengers and market share. We've got on-demand delivery services. We all now expect to be able to have something delivered to our toes tomorrow, or maybe within 2 hours. That's quite hard to do, actually. We've got public authorities who have increasingly engaged communities, who have better ability to comment and critique and shape policy. We've got infrastructure operators who are building roads, building energy systems for the next decades, for the next 50 years ahead or beyond. Land developers, similarly, other land assets. And all of us down here who are being affected by these changes, and mostly, we don't really care. We'd just like to go about our daily lives and do so efficiently. So what do? Well, what we generally do is we sort of look and think, that looks really hard. There's a big mountain over there that we might want to try and climb. How do we get there? And as a community, historically, we start trying to work on things on our own. We start trying to share information. We start trying to integrate it, bring it together, reuse the things that are good, enhance them, build on that, and then hopefully having a better chance of successfully playing those cards well and deploying this better future. So it's a bit, this is an icon analogy, but we've got these little temples of knowledge where we have a huge number of specialists in these different expert areas. We've any number of different technical disciplines within this tent and within that ecosystem. And we can all work away in our little temples of knowledge. After a while, we'll be able to build a library. We've got some reference material, we've got standards, we've got things we trust and we can refer to. And now what part of the challenge is now making that accessible, making it easy to use that and reuse it to make good decisions, to be able to have a taxi operator able to deploy an autonomous vehicle profitably, being able to understand how curb space could be managed differently. What should we do with infrastructure assets for energy, for refueling, and so on. Okay, and how do we put that in people's pockets so that they can do it easily? So in that context, we've been building out a set of technologies around data-driven scenario simulation. So we've got a big, complex problem with emergent properties where it's not obvious what the right answer is, and all of those different changes will affect one another. So simulation's used in lots of different industries to support that, and we've been applying that in this problem of transport and mobility. We've got much better data than we've ever had before. Open sources and increasingly premium data sources, robust providers, partners who can share information. We've got different people who are asking different types of questions, but they don't all share that. They don't all want to be completely transparent about what they would like to know next. But the mobility providers definitely care what the infrastructure is doing, and the infrastructure providers definitely care what the mobility providers are doing. So how do we build some simulation worlds? How do we play that game out? How do we test the different scenarios? And so we built this simulation platform. We've been able to show outputs from that plug into operational services to drive decision support, to be able to affect the deployment and delivery of those services or the infrastructure performance. And then in a lot of use cases, looking at future what-if scenarios. What if in 2025 we have fully electric everything? Well, what does that mean? And how is that going to be delivered efficiently, profitably, without blowing up our grid, and so on? Okay, so the project I want to talk about particularly is the opportunity that we had as a team and enabled us to go and bring this to life. So to take some of these ideas from being on a whiteboard to being technologies that run, that you can see demonstrating on our stand over there. So this was funded under the Intelligent Mobility Program and a CAV1 project, so a 3-year multi-partner collaborative R&D program, where we started off with a bit of paper and some people, eventually. Improbable, who are a UK computer gaming company, who went from being about 50 or 60 people when we started working with them to having $500 million from SoftBank put into them about 12 months ago. And Cubic, who run the Oyster card system and fare payment ITS systems around the world. So the idea was fairly simple. It's how do we build out a new generation of tooling to support the deployment of these future connected autonomous systems? Can we use these better compute technologies, some new data feeds, and a set of new bits of software to make that work really well? How do we deploy it in different places? How do we transfer that knowledge quickly from a test site to being able to understand deployment somewhere else where we haven't yet done testing? And as we started to come together with it, we realized that we needed to do this really quickly because these were capabilities that were needed in the market now. And very unusually for an R&D program, we've been able to deliver it in 27 months rather than 36. And this is effectively our showcase towards the end of the project, at the end of the project. So it's been a big success. So this is some of what you can see on our stand. So what we've got here is a world. It's a computer game world driven by data, and it's the West Midlands. So I think we're not quite on the map at the moment, we're just about down here, but there's about best part of 3 million people going about their daily lives in this world. And we've got different services running in it. So we've got a whole set that we built up in Coventry, taking particular data feeds, running particular types of service. There's a set here around Solihull, another set as we move around. But it's a multiplayer game. So the fleet operators are playing, they're changing the performance of what the system's doing. The infrastructure operator is closing roads, having incidents. So my colleagues are in the audience with tablets that are connected to that platform to be able to change the properties live as we're playing through a scenario. You can set up using from different configuration data to be able to play through all those different potential what-ifs, what might we want to do. We're drawing in open data to be able to give some level of reality to the world, so this is far from the best Unity visualization you'll see around this show, but here's a pull of the data, the building footprints, the road infrastructure, different fleets, the different operating status of the vehicles, their routes, their rerouting to avoid incidents, the passengers and the trips that are picking up, being able to test the effect of having a connected service that reroutes you around an incident, of being able to put more vehicles into service in order to adapt to a peak in demand, redistributing your fleet because the football match went into extra time and those 50,000 people aren't kicking out when you thought they were. All those sorts of use cases. And increasingly, how we can profitably deploy some of these new vehicle technologies into a service delivery. Okay, so, and that was mostly the morning peak. Okay, so one of the use cases of this technology has been in looking at autonomous rideshare services. So this is a consortium that was also supported through Innovate UK and Centre for Connecting Autonomous Vehicles, looking at connected autonomous rideshare services. So fast forward to 2025, you're in Greenwich, you're trying to look at tiers of mobility service. So how many vehicles do you need? What sorts of routes might they run? What would be the impact on mass transit or on buses or on congestion or on air quality or emissions? How do you take the best insights from each of these partners who have different commercial pressures, who have different visibility of the scenario? How does the city understand the potential impact of those services being rolled out? So we worked over 12 months to use some of these simulation technologies as a basis for testing alternatives. And I'm not going to go into huge detail on it, but some of the outputs allow you to look at, here's a shared minibus fleet operating through Greenwich. If we're running with EVs with a particular range and a particular recharge strategy and a particular set of depots and particular demand pattern, well, how are those vehicles used? When are they recharging? Where are they? What are some of the challenges? And how do you turn that into an assessment of your commercial viability, so the revenue you might gain from that service, but also the impact on the city of where those vehicles are and where those trips are coming from. So I think that's more or less my 10 minutes. Hopefully you have shared a few ideas, a few thoughts about what we've been doing and how some of them might be applied more widely in the industry as we start to take these technologies from working and vehicles that are safe and effective to being mobility services that we all use and we don't really notice or care that it's autonomous, connected, electrified or shared. Okay, thank you.